The overall concept of a computer is relatively simple. It's an electronic device that accepts user input, processes input according to a set of instructions, and returns appropriate output. This basic cycle requires a number of components to work together. To better understand what goes on each time we type a word or click an icon, let's take a look inside the average PC. The first thing you do when you sit down at a PC is turn it on. When you push that power button, you are actually sending a 5-volt signal to the computer's power supply. This signals the power supply to begin operating and transmit electricity to the rest of the PC's components. Where does that initial 5 volts come from? Well, even when your computer is powered down, it retains VSB, or standby voltage, so you can turn it on quickly. When a computer is plugged in, it receives power from a building's electrical system. Power from a regular electrical socket produces an alternating current. PCs require direct current to operate. So, the power supply is responsible for converting AC to DC power via what is known as switcher technology. First, the power supply raises the frequency of the wall power, which makes changing the voltage easier and reduces potential variances in the voltage. Then, the power supply lowers the voltage from 110 volts, which is standard in the United States, to the voltage requirements of the specific PC in use. Within a desktop PC, you can usually find the power supply in one corner of the casing. The unit usually contains a power cord and a cooling fan as well. So, it needs to have access to the outside of the PC case. If the power supply overheats, the computer will not be able to function, so it's important to make sure that the cooling fan is not blocked or malfunctioning. A power supply is rated by its wattage. When choosing a power supply, the wattage should be greater than all the power needs of the PC's other components. It is unwise to have a PC that uses 100% of a power supply's potential wattage. In the past, several types of power supplies were used. Recently, though, the PC industry has standardized the use of ATX-based power supplies. An ATX power supply will fit a standard case and work with a standard motherboard configuration. This standardization provides PC users with more options when choosing a new power supply. Once your PC is turned on, a number of other components begin their work. All of these components need to work cooperatively. So, before we look at each piece in depth, let's take a look at the glue that holds a computer's pieces together, the motherboard. The motherboard is essentially just a circuit board that would be useless by itself. However, every internal component of a PC is either on the motherboard or plugs into it through a port or slot. Some components found on the motherboard itself are the CPU, RAM, and BIOS. A motherboard's connections are made via electrical circuit paths called buses. The more information buses can carry, the faster data travels. Bus speed is measured in megahertz, which refers to how much information can be moved at one time. Some of the common connecting slots and ports a motherboard may have are the Peripheral Component Interconnect, or PCI, which provides connections for video, sound, and network cards. Then there's the Integrated Drive Electronics to interface with hard drives, and Universal Serial Buses, or USBs, to connect external devices. To connect the motherboard to the processor, it contains a chipset. The chipset has two parts, called bridges, that connect the processor to the motherboard and, subsequently, other PC components. Chipsets are permanent parts of the motherboard, and manufacturers design these products to work with specific processors, which optimize performance speed. In addition to matching a chipset to the CPU, computer construction also requires a consideration for the motherboard shape, also called its form factor. This determines what type of casing the motherboard can fit inside. To simplify PC construction, most motherboards take one of several official form factors. In addition to using common shapes, motherboards have been standardized in other ways, such as the CPU socket connection. This means that several types of CPUs can be used with the same motherboard. Once powered up, the first commands a computer receives are from the BIOS, or Basic Input-Output System, which is contained in a read-only memory, or ROM chip, located on the motherboard. The BIOS chip contains permanent information telling the computer how to load devices and programs when the computer is turned on. The first thing the BIOS does is check the information stored on the A-complementary metal oxide semiconductor, or CMOS chip. The CMOS setup provides detailed information about the computer. The BIOS also performs a power-on self-test during any cold boot. A cold boot means the computer is not simply restarting. The BIOS determines this by checking a specific segment of the computer's memory. On many computers, the monitor displays information that the BIOS encounters during its setup. Some of the BIOS's other jobs include checking the video card, testing the RAM, and identifying the keyboard and mouse. It finally loads the operating system software and turns control of the computer over to the user. With the PC up and running, let's move to the brain of the computer, the central processing unit, also called the CPU or microprocessor. The CPU is located on the motherboard. It oversees every operation a computer performs, which is impressive when you consider it is just a few square inches in size. Within the chip, there are two parts, the control unit and the arithmetic logic unit. The control unit consists of circuitry that sends electrical signals to all other parts of the PC and provides them with instructions. To accomplish this, the control unit finds information from the PC's memory and translates it into commands. Meanwhile, the arithmetic logic unit's job is to execute commands and send results to be stored. The arithmetic logic unit can perform basic mathematics calculations and make logical comparisons. Combined, the CPU's two parts produce the machine cycle of a computer. A CPU is rated based upon its data processing speed, which is measured in gigahertz. We rely on our computers to not only perform tasks, but also to store valuable information. Much of this data is contained in the hard disk drive, often simply called the hard drive. Hard drives contain one or more platters where data is stored. Each platter has a disk with magnetic recording material on top of it. The disk spins via a motor as it records and reads information. Larger hard drives have multiple disk platters. To keep a computer functioning smoothly, the hard drive needs to work quickly. So, platters can spin at speeds of more than 150 miles per hour. To protect the platters, hard drives are usually sealed in a metal case. Inside the case, there is an electronics board that controls the read-write mechanisms and the motor. The read-write mechanisms are attached to an arm that move to the appropriate place on the disk when information is required. When a program running on the computer requests a file, the hard disk retrieves its bytes and sends them to the CPU for processing. Information on the hard disk drive is divided into sectors and tracks. Each track is a full circle on the disk, and each sector is a wedge on the disk. The hard drive is classified by its storage capacity in gigabytes. There are also two ways to measure the performance of a hard drive. The first is data rate, or the number of bytes per second a drive can transmit to the CPU. The second is the seek time, which is the time between a CPU request for data and the start of that data's transmission. Like the motherboard, hard drives also have several standard form factors to make swapping them out easier. The form factor is designated by the hard drive's volume in millimeters, centimeters, or inches. When choosing a new hard drive, the form factor needs to match the computer's casing. Other factors must be looked at as well, such as the hard drive's power consumption in relation to the computer's power supply. Not all information is stored permanently on the hard drive. Instead, information a computer needs to access quickly may be stored in its RAM, or random access memory. Each time you load a program, information about that program goes into the RAM, where it can be easily accessed by the processor. When you shut down your computer, the RAM is reset and data is removed. The more RAM a computer has, the quicker it can respond to user commands and solve problems. Computers with more RAM are also better at multitasking and running more than one program at a time. RAM is embedded on a microchip that is usually found on the motherboard. The chip contains an array of cells, each of which can hold one bit of data. To read data in binary, each cell is set to either a 1 or 0 depending on its electrical charge. Each cell on a RAM chip has a unique address. So, when the processor needs information, it sends an electrical signal to the specific address of the required data. While a PC will come with some RAM, a user can usually insert additional chips or swap out existing ones. RAM comes in increments starting at 16 megabytes and increasing in multiples of 8 megabytes. Most of today's RAM is considered DDR, or a dual data rate. This means that the memory can transmit data twice per each clock cycle instead of once, which makes the memory faster than previous RAM chips. Yet another way to classify RAM is by whether it is static or dynamic. Dynamic is the more common type of RAM, in which each cell on the array has a capacitor. This capacitor holds a charge, which determines the cell's value. In contrast, static RAM uses a transistor chip, which can be set to on or off to designate 1 or 0. Finally, RAM is classified by its layout. There is single inline memory, dual inline memory, and small outline dual inline memory. We use our computers for gaming, music, movies, and more. For a computer to produce sounds for such media, a sound card is usually utilized. A sound card is a circuit board that can process input from a microphone or other audio device. It also transfers computer information into sound for output via the computer's speakers. To accomplish this, the sound card must be able to transfer between analog data, like sound waves, and digital data. In other words, it is changing information from waves to bits. To do this, the sound card takes precise measurements of each sound wave. The number of measurements per second, called the sampling rate, is measured in kilohertz. The faster a card's sampling rate, the more accurate its reconstruction of the wave. To produce the sounds that we hear out the speakers, computers can use several methods. One is frequency modulation synthesis. For this, a computer overlaps sound waves to create complex sounds. Another method is wavetable synthesis. This method tends to be more accurate and requires the sound card to use small samples of real instruments to recreate sounds. A basic sound card will include four main components. It needs to have an analog to digital converter, as well as a digital to analog converter. It also requires an interface with which to connect to the motherboard, and an input-output connection for devices like microphone and speakers. To simplify a sound card's construction, it may use a single decoder chip for both the digital to analog and analog to digital converters. This is called a codec. In addition to the four basic components, some sound cards are equipped with additional features to improve performance. One example is a sound card with a digital signal processor, or DSP. A DSP can perform its own conversion calculations without having to rely on the CPU. This lowers the CPU's workload. Another example are cards with extra connections available. A sound card equipped with multiple speaker connections offers surround sound capabilities, while one with musical instrument digital interface, or MIDI, can connect to electronic instruments. It is important to note that some motherboards have integrated audio support, which can function in place of a sound card. However, the best audio quality relies on this dedicated component. While audio information is the responsibility of the sound card, visual information is processed by the graphics card. The graphics card is responsible for the images you see on your monitor. It translates information from binary data into pixels, which are tiny dots of color that make the pictures on your screen. When a program decides it needs an image, it sends information to the CPU, which passes it on to the graphics card. The graphics card then decides how pixels will need to be configured to create the image, and sends this information onto the monitor. To accomplish all this, the graphics card needs the help of other computer components. It uses the motherboard to connect to all these parts, and also to receive power from the power supply. A graphics card with its own processor is said to have a graphic processing unit, or GPU. Just like the sound card's DSP, the GPU can perform its own calculations and solve problems. In some cases, a GPU has more transistors than a standard CPU. This is a testament to how powerful graphics cards have become with the advent of high-quality 3D animations. To make a 3D image, the graphics card starts by rendering straight lines. It then fills in the remaining pixels in a process called rasterizing, and adds color and texture. To keep up with fast-paced animations, the computer needs to render new images roughly 60 times per second. The number of frames a graphics card produces each second is called the FPS. This speed is how graphics cards are usually rated. Other parts of the graphics card will affect its speed as well. Two of these are the GPU clock and the amount of available memory. Like the sound card, the graphics card is not necessary on computers with graphics capabilities built into the motherboard. However, computers with dedicated graphics cards can produce better visual effects. CD-ROM disks are optical storage devices commonly used by PC users to load software, watch movies, listen to music, and much more. In order for the computer to access data on a CD, it requires a CD-ROM drive. The CD-ROM drive reads information off a disk by using a laser. The laser is designed to reflect off the CD and into a photodetector. While you may not be able to see it, a CD actually has tiny pits carved into it. When the laser hits a pit, its path is disrupted and it misses its sensor. The pattern of sensor hits and misses can be decoded by the microprocessor and sent as usable data to other PC components. In binary code, each sensor hit is a 1 and each miss is a 0. The CD-ROM drive has a motor that drives the disk and the laser assembly. The faster a CD is spun, the faster its data can be transferred. For example, a 52x CD drive can transfer 7.62 megabytes per second. This is 52 times the standard speed for the reading of an audio CD. There are several variations on the typical CD-ROM drive. Technically, a CD-ROM refers only to a compact disc with read-only memory. DVDs or CD-RWs, which can have data written onto them, require disk drives that can handle them. There are also CD-RRW and DVD-RRW drives that are capable of burning new data into these disks. In order to connect a PC to the Internet, it needs to have a network card, which is the hardware interface between a computer and a network. A network card is designed like a basic circuit board, and either located directly on the motherboard or connected to it via a card slot. Different types of network cards are configured to connect to different networks. For example, an Ethernet card allows a PC to connect to an Ethernet network, while wireless network cards allow for connections to wireless networks. In order for the network card to access the network, it needs to have a wire or a transmitter. In the case of a wired network, a port for the appropriate cable is usually embedded into the card itself. For this reason, network cards are often directly connected to the PC's casing. For a wireless network, the network card may be directly connected to an antenna on the computer's casing. The network card's main role is to translate data so it can be transmitted across a network. Information for a network is first processed by the CPU before being sent to the network card. As with other PC components, this is just a brief overview of network cards and their function. With all these pieces of hardware, there are a number of variations that can exist from one PC to another. However, the general function of each component remains the same, and understanding each one can help you see just how your computer works from boot up to shut down.